Well, good evening, buenas tardes. It's wonderful to be here. My name is Katherine Bennett, and I'm the CEO of the High-Value Manufacturing Catapult. My first visit to Barcelona, to Catalonia, and of course, partnership with Spain in terms of research and technology is absolutely key for us in the UK. So a real honor and a pleasure to be here. I'm just going to do a very quick introduction into what the High-Value Manufacturing Catapult is. It's a part of the UK innovation setup, and then I'm going to hand over to my colleague Rab Scott, who's going to talk in more detail about the work that we're doing in digitalization, digital twins, etc. So as you can see here, a map of the UK. You can see the sites there that make up the catapult that I have the honor of leading. So the catapult is all about helping bridge the gap in the UK between academia and business. And the 7 centres across the UK are absolute centres of excellence in many different parts of how we can help the UK industry and beyond in terms of top talent, sectoral expertise, and support to businesses. We have 22 locations across the UK, and since we were created by the British government 10 years ago, we have worked with over 22,000 companies, and half of those companies were SMEs. And of course, I know to many of you, maybe from other parts of the world, supporting small business is absolutely key. So just a quick slide there, and we're very happy to share the slides with you in due course. What is it that we actually do about the catapult in terms of helping manufacturing? So it is all about business growth and scaling, how we can help companies who may wish to learn more about manufacturing techniques. We've got a very strong convening power with the experience we've gained over the last 10 years. Of course, technology development, which is what we're all here to talk about today. All important supply chain development. One of our centres specialises in nuclear technology, has a particularly strong programme on fit for nuclear, how we can help the future energy needs of our nations. Skills and training is another part of our work. Initially, it wasn't always going to be something that Catapults looked at, but you cannot talk about business growth, you cannot talk about business innovation, you cannot talk about supporting small companies if you don't also help them with advice and support on skills and training, and that's a really important part of what we do now. Problem solving. All the engineers I have the honor of working with love to solve problems. And of course, all importantly, affiliation with the top brains in the UK and around the world in terms of manufacturing expertise. So it's all about impact. How do we measure ourselves? What do we do? And as I said, we were founded 10 years ago, and we very much have seen how we've helped companies increase resilience. And at some of the sessions I've been at earlier today here at this conference, resilience has been a subject that's talked about a lot. Net zero, another topic I know very important to the IoT. How we can help manufacturing companies reduce waste and emissions. How we can help build supply chains. And of course, further to what I said about skills and talent, how we can really find and develop that talent. How can we find the next tranche of engineers to help us tackle the net zero challenges? And many of them, of course, in the digital space. Another part of work we do, working very closely with Innovate UK, who are part of the government in the UK, who are the innovation funding agency, looking at future investment. So it's been, again, great to meet people here today who are looking at opportunities for investment. And then, of course, making ourselves fit and ready to improve products to the market. And that's all part of the circular economy, future materials, and developments in that space. So that's the catapult. I'm now going to hand to Rab to talk more of some case studies, the work we're doing in the digital space. Rab.
Thank you, Katherine. I realize that I'm standing between you and the awards ceremony, so I will keep this short. But really, what I do as Chief Engineer for Digital Manufacturing within the High-Value Manufacturing Catapult is really try and knit together, to weave together the activities across all 7 centres, all 22 sites, to provide value for the UK manufacturing base and wider. Because you can't take the manufacturing base on its own. You've got to look at it as part of a system of systems. And that's the sort of terminology that we come across day after day when we're beginning to talk about the IoT. So today I'm really just going to touch on what the IoT means to manufacturing, but more importantly, what it means to manufacturing SMEs. SMEs, small and medium-sized enterprise, that's, some people call them SMBs, but they make up more than 90% of the manufacturing base in the UK. And it's vitally important that we bring them along with the latest technologies so that they can communicate and work with the large OEMs. But let's just take a little step back. Lord Kelvin, about 100 years ago, said, if you cannot measure it, you cannot improve it. And improvement is everything that we do. We want to improve productivity. We want to reduce our waste, improve our productivity. We want to really improve our skills base. We want to improve our use of energy, our use of resources. But to do that, we've got to start by measuring it. This is a quote that a lot of you will probably resonate with. Imagine every piece of equipment monitoring its own operation, including uptime, downtime, dwell time, energy usage, malfunction and repair time. Technologies exist right now that can do that to help end users manage their assets. But look at the date. That was said in 2003, so what's actually changed? You know, you read that to someone today, here today, and they think, that's the IoT, that's industrial IoT. So what's changed? What has changed is we can do it better, we can do it faster, we can do it cheaper, and we can do it across more of our supply chain. And that's what I'm going to touch on now. 10 years ago, Hannover Messe 2011, we got the launch of Industry 4. A connected world where data could be accessible to the right person at the right time in the right volume. Improving products, improving productivity, reducing costs, energy usage, and time to market for new products. And also giving a better workplace for all. If you were at the talk yesterday around Industry 5, Industry 5, have we just got another industry? No, we haven't. It's really all built around the fact that the dystopian view of Industry 4, where there were going to be 2 employees in the factory, a man and a dog, and the man was going to be there to feed the dog, and the dog was going to be there to make sure the man didn't touch any of the machines. That hasn't come true, because the human still needs to be at the heart of the operation, doing what humans do best, and that is problem solving. Biggest problem that we've got is all about non-value added activity. You know, yes, we can set a value on a torque wrench, but you get the system to do that, and you'd have confidence that the system had set it at the right value. You can get someone to count the number of products coming off the end of a line and the quality of those products, but the system could do that, and you'd probably have more confidence in what the system did. You could have someone working out where things are in your warehouse, but the system can do that. You could have someone pushing a trolley around your warehouse, but the system can do that. You could have calculations being done, but the system can do that. So why aren't we allowing the system to do this? And that's because we need to educate people. We need to educate people and allow them to actually interface with the system. By giving them the possibility to access that system, interface with the system, more quickly, you can have better decisions more quickly. And that's really where the value comes from. In any process, there are 3 latencies. There's the latency of capture between the event happening and you capturing the data. There's the latency between the data being captured and it being analyzed. And then there's the latency between the information being delivered and the action being taken. If we can compress that, we can be more productive. We can make those better decisions more quickly. And this is where the Industrial Internet of Things and SMEs come together. This is where we can start allowing those workers on the shop floor to access that information, access that data, and make those decisions. And it can happen across a really broad range of activities. So, the typical one that we see is operational equipment efficiency. I don't know what it's like in other countries in Europe, but in the UK, yes, I know we're no longer in Europe. I'm talking about the geography, the continent. In other countries in Europe, or in Britain at least, a small and medium-sized business will turn its machine on at the beginning of the day and turn it off at the end of the day. Does it know what it's been doing during the day? It hopes so. It'll have given it a job sheet, and hopefully the work will have been put onto that machine. But has that machine been cutting all the time? Has it been doing its job all the time? If not, why not? Because if it's been on but not cutting, it's costing me money. If it's been on and it's been cutting, hopefully it's creating me a product that I can sell. But if it's doing the same product today as it did yesterday, are they both of equal quality? Well, by introducing things, simple things, like the IoT devices perhaps that you see on the right up there, you can start monitoring that. You can start informing without having to go down and check that the machine's on. So you can start looking at the information. The example that we've got there is actually one of my colleagues at one of the high-value manufacturing centers who's got a 1956 lathe that we have retrofitted with sensors, and those sensors are now being dashboarded up on top, giving you simple things like vibration, energy, temperature, allowing you to make those informed decisions. And by the time you start to do that, you see that data can actually inform you and tell you other things. It'll tell you about the energy efficiencies. Perhaps it's more productive or more cost effective to use that bit of equipment at different times of the day. In the UK again, if you run it overnight, then you pay less for your electricity than you do if you run it at peak time. So this is where we can start understanding the opportunities for things like smart scheduling. But you can only do that based on fundamental data to begin with. So we can become more productive, we can have better operational efficiency, purely by understanding is that machine on or off. You can look at the energy efficiencies. If I've got a part that's being made today, and it was also made yesterday, actually the power profile, the vibration profile, the temperature profile should ideally be the same, taking into account ambient temperature variations, things like that. If it's not the same, one of those parts has the potential to be better. So do you know which, and do you know why? The next step is actually looking at predictive maintenance. If you can look at the variation in your signals over time, and by the way, I know I'm preaching to the converted. You wouldn't be here at the IoT World Systems Congress, it's not quite right, Solutions World Congress, if you didn't believe in this already. But predictive maintenance is possibly where the IoT is going to provide the greatest value to SMEs. Because if we can understand what's happened, you can have hindsight. If you can understand what's happening now, you've got insight. But if you can layer your insight with your hindsight, you can have foresight, and you can start looking at where that trend is going. A couple of examples here then. So, this is some work that we did with a local company. This one was actually up in Sheffield. We put on some cheap, I won't say cheap, inexpensive current clamps. So just measuring the power consumption from that particular piece of equipment. These just go around the main power feed. So immediately we're overcoming one of the barriers that SMEs quite often raise. What about cybersecurity? By having the current clamp external to the system, it can't actually influence the system. It can monitor the system, but you can't actually influence it. So theoretically, someone should not be able to hack into that current clamp and change the system at all. So that removes one of the barriers to adoption in a lot of cases. What we then did was we recorded the power signature of each manufactured part. We then correlated that power signature into an algorithm to classify the number of parts created and the type of part created, because everything's got its own unique signature. So we developed an algorithm, AI algorithm with this, and it was run on a lightweight, low-cost Raspberry Pi solution. What this allowed that company to do was remove the non-value added activity of having someone sat there counting the parts that come off the process. It identified where quality was becoming an issue. Some of those spikes and peaks were actually identified due to a flaw in the material. And all of that meant that their productivity went up. In my previous slide, we've got typical IoT sensors there. You've got the Amazon monitor on at the bottom, plug and play, send stuff to the Amazon Web Services. You've got our proprietary one at the top. These are really now breaching the cost barrier where it is perhaps £100 to implement. You don't need data science capabilities because the systems will analyze it for you. What's most important these days is actually the data engineering, not so much the data science. Understanding how you place those sensors, how you capture the data, how you cleanse the data, how you structure the data. Worry about the analysis later on. And those are some of the services and support that the High-Value Manufacturing Catapult offers to local companies. We then move on. One of the biggest themes that I've seen at the conference over the last few days, if not out in the main area, but definitely in the auditoria, is really talking about digital twins. And for me, the important thing here is to understand that if you put two people in a room and ask them to define a digital twin, you'll come up with 3 answers. Hopefully, you'd get one that's agreed on. But we are moving towards what's shown at the bottom of this slide. There is now an ISO standard, 23247, which is a digital twin framework for manufacturing. And for me, the important thing here is what's actually said in that part of the quote. It's a fit-for-purpose digital representation, so a model or simulation, representing an observable manufacturing element, so a physical entity, with synchronization between them. So really, you've got to have a virtual side, you've got to have a physical side, and they've got to be joined. Until you've got those 3 elements in place, we would argue you don't really have a digital twin. You might have the foundations of a digital twin because you don't have to start with a simulation. You can start with the physical and work back, or you can start with a simulation and work forward. But with a digital twin, that connectivity is really enabled by the industrial Internet of Things. The majority of manufacturing hardware in the UK at the moment was never intended to be connected. We're talking about legacy systems. We're talking about legacy hardware. And the IIoT is really the enablement to connect that legacy equipment and hardware. And only by connecting it and deriving that data and extracting that data and contextualizing that data within the digital representation, do you actually have that digital twin? And of course, once you've got your digital twin, you can do a number of things. You can just derive insight. You can watch it and see what's happening. You can replay it and see what happened yesterday, or you can look at it in terms of predictive maintenance and see what's going to happen tomorrow. But it's not just for you that it's of value. As we move forwards and we start really addressing the net zero challenge by looking at your scope 1 emissions, by looking at your scope 2 emissions, by looking at perhaps what's hardest, your scope 3 emissions, you're going to have to reach out into your supply chain. You're going to have to reach out upstream and downstream and start to share data, because their scope 2s and their scope 1s are your scope 3s. And you've got to have confidence in that data. So suddenly, the implementation of a digital twin takes away a lot of the non-value added activity that potentially exists in sharing data to overcome the challenges of net zero. And as we move forward, probably with carbon accounting taxation, you're going to have to prove the data that you're sharing. What better way to do it than giving people access to that digital twin? No overhead, just a connection. Bearing in mind cybersecurity, of course. The big challenge that we see with digital twins moving forwards is again one of the other words that I'm picking up across the board at this event, and that's interoperability. If I had a manufacturing digital twin, perhaps of an air conditioning unit, and I embedded it into the digital twin of a building, they've got to talk to each other. There's got to be a level of interoperability here. And yet, at the moment, we're really facing the fact that different sectors, different domains, use the same words, but a different language when we're talking about digital twins. And that's why the slide that I'd expected to come next will actually come after that one. But that is why we need to address the interoperability of digital twins. But my second last slide is really just a conclusion on the IIoT. And that is really important for manufacturing. And it can deliver real benefits really quickly. You can implement an IIoT monitoring solution in a matter of tens of minutes, I would have suggested. And it can start paying back in that same sort of time frame. You don't have to be a global OEM to start benefiting from that. You might be a global OEM that benefits from an SME that has got IIoT in it. It doesn't have to be expensive to get started. A few tens of pounds, a few hundreds of pounds. It doesn't appear only at one particular part of the manufacturing life cycle. And if you haven't started, and this is where Katherine will smile, there is a Chinese proverb that is the best time to plant an oak tree was 100 years ago. The second best time is now. And I would say exactly the same exists for your IIoT journey. If you haven't started it, what better place to start it than here and now? Just rewinding to the comment on digital twins. Recently, UK government has invested in bringing together communities within the digital twin space to get them talking, to understand what the language that each domain is talking about actually means, to understand where the overlap is, where the differences are. And this has been developed under a program called the Apollo Protocol. Apollo very famously had another twin called Artemis, and we've seen this coming through the Gemini program with NASA. Gemini was followed by Apollo. They've now got Artemis. In the UK, we started off with the Gemini principles, which was looking at digital twins for the built environment. We're now moving that into the Apollo protocol, where we're bringing environments together. So this is an evolutionary stage in the development of digital twins ontologies, and the semantic framework behind that. Because only by having digital twins talking together through the industrial Internet of Things can we really extract the value that we want and start addressing the challenges of net zero. We are the High-Value Manufacturing Catapult. We're funded by the UK government to help manufacturing. Come and talk to us. Thank you. We do have time for questions if there are any questions, but I do realize that I am standing between you and the award ceremony. Okay. Thank you for attending, and enjoy your night.